Welcome back to the DASYLab training. This training will make the most sense if you have watched the previous modules. Module 2 is the start of the hands-on exercises. We'll start with data logging, where we will use a data acquisition device to log data to the hard drive. You can use the device of your choice, or you can use the built-in sound card driver to be able to do the same thing as the exercise demonstrates with a measurement computing device. A data logger simply saves the acquired data to the hard drive. Typical applications include a display and scaling, and it's a building block for almost every application. We're going to create a simple worksheet with a one-channel analog input, display to a digital meter, and then we'll log data initially to the hard drive using the Write Data module in DASYLab DDF format. The first step to create a data logger is to open the input-output group of the module browser, open the desired driver group. You can use the IoTech sound card or demo driver, the Measurement Computing MCC DRV driver, or any other driver that you have configured. Select the analog input and place it onto the work area. Select the device and channel group if you're prompted for it. I'll show you a quick animation of how that works. First, create the analog input by selecting it from the input-output group. Drop it onto the work area. It's going to prompt you for the channel group. Select the channel group and select OK. The next step is to display the data. You'll create a digital meter module from the display group and then connect it to the analog input module. Close the input-output group on the module browser, open the display group, select the digital meter module, and drop it onto the work area. Connect using the Touch and Connect method, and then use the Restore All button to restore the display from the bottom of the screen, and in my case, I'm moving it into the display area. Click Start, and you can see that I am logging data. Now we'll add a Write Data module from the Files group. You'll connect it by branching the wire. I want to note that no data is saved to the hard drive until a Write Data module is added. There are other save functions, including the DDE output to Excel or another program, and the ODBC database output to a configured database. You can select the one that works for your application. Close the display group, open the Files group, add the Write Data module, and branch the wire to connect it. The Write Data module always needs to be configured, if only to give it a unique file name. So create a file name. I'm calling this one Exercise 1. You click Open. You click OK. I've wired it already, so all I need to do now is hit Start, and it's logging the data to the hard drive. You can see that the file was created in the DASYLab data folder. Now I want to add scaling and the multi-file feature to the Write Data module. We're going to modify the worksheet to add the scaling module. We're going to rearrange the worksheet, creating everything in series. And then we'll modify the Write Data module to change it to CSV data and to enable the multi-file safety feature. This enables you to create a new file every time you start the measurement. After rearrange the existing worksheet, I'll start by deleting the channels coming from the analog input, and then I'm going to move the modules that are already there to make room for a scaling module. Open the mathematics group, select the scaling module, select the linear scaling mode, and then connect up the modules. The digital meter doesn't have an output. Open its properties and check the copy inputs on the lower right in order to create a pass-through output for it. Now you've got the 4 modules, analog input, scaling, digital meter, and the write module in series. Let's reconfigure the write module to change it to a CSV file. There's always this warning message, just click yes. Now configure multi-file by enabling it, appending to the file chain, and to change the number of blocks to 0 so that it only creates a new file when you hit the Start button. Click OK now, and go to the scaling module where we will configure the scaling. Open its properties, I'm going to do volts to PSI, but PSI isn't on the list, so I have to type that in. And I'm going to use the 2-point scaling, where at 5 volts reading in, I have 10 PSI of pressure. Click OK. And now when you click Start, you're going to see that the digital meter is showing you a larger number as well as the PSI units.
Let's talk a minute about displaying data. If you want to view data over time, you can use the chart recorder, the YT chart, the XY chart, the polar plot, and the diagram module to plot the data. The list module acts like a table where it gives you a list of numbers, but it is still showing you all the data points over time. These functions display every sample. You can set them up to customize the display. You can change the axis settings, the time interval, the zoom, and the colors and lines. The modules that include the digital meter, the analog meter, the bar graph, and the status display all give you a data snapshot of the most current data point. You can also customize them so that they display different digital formats. The status display can display custom bitmaps, and in the case of the digital meter, if you have a block size larger than 1, you can configure it to show you the minimum, the maximum of the data in that block, and you can also configure it to show you an RMS. I want to add a chart recorder to the work area and connect it in between the digital meter and the write data modules. I want to restore the displays and then run it.
I'll start by making room by moving the write data module to the right after deleting its input channels. And then I'm going to go to the display group and add the chart recorder module. Drop it in, it automatically opens up the properties window, so I need to select copy inputs in order to put this in series with the other modules. Click OK, now wire it up using the touch and connect method, and restore the display window. I'm going to move it into this work area and rearrange the digital meters so that we can see them both at the same time. I have an x-axis and a y-axis. I'll click Start. You can see that the data is being plotted at the very top of the screen, and then it's coming down to about 2.5 volts. If you look at the digital meter, you can see that the data range is about 2.5 psi up to about 15 or 16 psi. So I want to change the y-axis settings by clicking on the y-axis button on the toolbar, and I'll change it to 0 to 20 psi. And it will let me visualize the data. It's a nice sine wave going from about 2.5 psi up to a little over 15 psi. I can display the y-axis unit by going to the display menu, selecting Windows, and selecting Display Y Unit, and you can see that PSI is now shown above the y-axis. I can change the x-axis as well. If you click on the x-axis button, you can see that it's displaying about 60 seconds worth of data. I'll change that to 5 minutes. Click OK, and now you can see it kept all the old data, but it's giving you a lot more room. It's showing you up to 5 minutes of data. I can now use the zoom cursors in order to display a smaller amount of time. And you can see that I'm now zooming in. I'm going to zoom in again. Now, once you've zoomed in the chart recorder in particular, you have a scroll bar at the bottom that allows you to scroll back through all of your data. Now that we have a chart recorder, let's talk about the chart display windows. Much of this will also apply to the YT chart, the XY chart, and the polar plot module. The display window associated with the module has its own set of menus. It includes the axis menu, which also includes the time scale, how much data you're displaying at one time, as well as the y-axis settings. You can display a header on the chart recorder. You can change the chart recorder from one chart to multiple charts. You can do cursors and zooming, and you can change the colors and lines. You can change the appearance of the chart. So what I want to do is play a little bit with the display windows and changing the x-axis, the y-axis, the line weight and color, turning on the grid, changing the grid color, zooming in and out, also looking at the cursors. While your measurement is running, you can easily change the y and x-axis settings. Let's start with the x-axis settings. The quickest way to change it is just to simply double-click on the x-axis itself. That will open up the Chart Recorder X scaling, where you can configure how your x-axis looks. Let's change it to fixed, so we have a fixed interval of time. The scaling is automatic. Right now, we are looking at time of day. I'll change the time format to be minutes and seconds. And the step DX, 20 seconds, let's make that 30 seconds. And I am also going to change the display range, the total amount of data being displayed on the bottom. I'm going to change that to 5 minutes. So that's in the maximum display range. DASYLab will offer you a possible maximum number based upon its memory constraints. So I'm going to allow 5 minutes and click OK. So now I am displaying 5 minutes of data. I have got a fixed axis, and you can see the fixed axis is going from -5 to 0. I kind of like the 0 to 5. So I'm going to stop the measurement, and I'll open the x-axis again and do my curve from the left. And that way we will see from 0 to 5. You're also going to notice that there's a tick in between each of the major numbers. And let's make it wider so we can see the tick. That's going to be 15 seconds. So you're going to have 0, 15, 30, 45, 1, 115, 130, 145, 2. So start the measurement. And you'll see the data is now plotting starting from the left of the screen. Now the amplitude of the data, the chart recorder does not have a way to auto scale the data. As the data exceeds the range being displayed, it is going to just peg out at the top and the bottom. You can double click on the y-axis and change the y-axis scaling while you're running, and I'm going to change it to plus or minus 20. So now that I can see the data in the data range. We looked at previously going to the display, going to window, and saying display the Y unit. So the Y unit is being displayed above the axis. You can turn on a grid. The grid, by default, is this ghastly color of green, and I personally think it distracts from the data rather than enhances the data. The grid is showing you the data based on the major grid points or the major axis points. So at minus 20, minus 15, at 30, 1, 1.5. So you can change the colors and lines of almost all aspects of this display. There's a paintbrush icon on the function bar, and in the display menu, there is a window and then colors and lines. Both get you to the same window that allows you to change the display elements. Let's change the drawing area. Currently it is white. If you change the color, you get a standard palette of colors, and I'm going to change it to a, let's say a gray. I'm going to make it a light gray, but I want to go to custom colors and make it lighter than the light gray that they choose. And so I'm going to click on OK and OK. And now my display area is in a lighter gray. Remember I said I didn't like the grid color, so I'll go to colors and lines again. I'll select grid. I will change the color of grid, and I'm going to make it a dark gray on top of that light gray. So now that I've got a grid that isn't green, my data line is showing up in red. I can change the data line color. Click on color, change it to, let's make it a blue. And I can change the line style. You've got a choice between a bunch of different line styles. There are some that are for continuous data, solid dash, dotted dash dot, dash dot dash. These help you if you're printing on a black and white printer. Crosses, circles, triangles, squares are for discrete data, where you only want to see the single data points. And cross line, circle line, triangle line combine the continuous with the crosses, circles, triangles. And then you also have just the ability to use a pixel or a dot. I'm going to increase the line weight from 1 to 2 and click OK. I have a nice blue line. You're going to notice the axis color changed to match the line, and the legend at the bottom, the color of the text as well as the line changed at the bottom. You can zoom. There's a zoom cursor, which will allow you to zoom in and out on your data. You can unzoom. And when you unzoom, for example, I zoom in, let's do it in a bunch of different steps until I get down to one. Once I've zoomed in, if I zoom out, I click once, it goes back the previous zoom, and then we'll zoom all the way back out again. In effect, DASYLab only has one level of undo. So you can undo to the previous zoom step and then all the way back out again. So I'm going to zoom back in again. Now the next feature to look at is cursors. Cursors are in the survey menu, and if you say enable survey, it turns on a cursor, which is a dark line and a new box on the screen. The dark line is hard to distinguish from the axis lines, so while you're doing this, you may want to turn off the grid just to make it a little bit easier to find these lines. So you can take these lines, for example, and position them on adjacent peaks, and you can see that DASYLab thinks that the time between those peaks is 7 seconds and the frequency is about 14/100ths of a hertz. It shows you the y-axis value, and now the data has caught up to where I'm zoomed. The data underneath the axis changes as I am viewing the data. In addition to these vertical cursors, you can go to the cursor window and turn on an extended cursor, which gives you additional information about each one of the cursor lines. So you can compute, in addition to dt and frequency, you can get the dy dt, or the slope, the minimum, the maximum, the integral, and the RMS. You can also go to the cursor window and turn on a horizontal cursor, and the horizontal cursor will give you a horizontal line that follows your movement of the vertical line, that allows you to better position where those vertical lines are. Now, because the data is moving, I want to get back to stationary data. Oh, that's not going to happen. I'm going to stop the measurement just so we can see this a little bit better. So if I pick the peak and the minima, then you can see that it takes 3.28 seconds to go from the maximum to the minimum of the data, that the RMS of that data was 5.67, the integral was a negative 0.57, the minimum was 7.69 negative, and the maximum was 8.36. Not a very symmetrical signal, is it? So you've got a lot of power of what you can do in the cursors. You can also configure these cursors to be able to save this data either to a file or to variables. In the survey menu, under Cursor Data Format Variables, You can configure cursor data to be saved to different variables. You can determine if you're going to save cursor 1 time, cursor 1 value, cursor 2 time, and cursor 2 value. Please note, for these variables, if you have multiple channels, in effect you're defining a variable range. So, for example, your cursor 1 time value, you might want to start at variable 100, and cursor 1 y value start at 116, cursor 2 start at 132, and cursor 2 y values start at that next interval. I'm not doing the math in my head. So that's where you would say save the data from all channels. You can also compute here whether you want to show an integral or a mean value. And you can also do the variance and the standard deviation to different variables. Again, if you've got multiple channels, you're going to need to give yourself a variable range based on the number of channels. You can also, in the survey menu, define save cursor data options. You can save the cursor data to a file on your hard drive. In this case, it's saving into the DASYLab default data folder with a file name of defcur.ddf. So this could be my exercise 1.ddf. Wait, no, cursor. So we can save the cursors. You can choose an ASCII format. It will automatically change the extension. You are only being given the option of using the .asc extension. Here, you would then determine how you want to do your separator for your data separator, your decimal separator, and how many decimals you're going to store. And then what kind of a time format do you want to store in that file? So if I do a survey and then I say save cursor data, it's going to create a file somewhere on my computer. Let's see, data folder. Let's open up a data folder. Bring it over here. So I have a data folder where I've got exercise 1 cursor. I'm going to open this up in a text editor, also on another screen. And you can see that what it did is it stored the cursor values with the timestamp and just the cursor value. So there was a setting that I missed. Let's go check the settings. Back to DASYLab, back to the survey, save cursor data options. I would like to save all the cursor data between cursor 1 and 2 on all channels in ASCII format. So let's do that again. Survey, save cursor data. Turns out this file will update. And now I have got a file that has all of the cursor information in it. Let's make this visible on the screen. So it starts with a header just like any other DASYLab data file. It starts with the beginning of that cursor range and it saves all the data down to the bottom of the data range. So this is a way for you to analyze your data manually by digging in with cursors, getting data points. If you want to visualize what that value is, if I click on the first cursor and click the space bar, it drops a little text label that tells me the time and the data value on that cursor. And as I move the cursors around, I can keep doing it. Those labels are going to follow the data. They're actually going to disappear right now when I start the measurement again. They're going to stay on the screen for associated with the previous data. So once the data gets over to this time value, then you're going to see the cursor line up with the data. I can delete them by double right-clicking on them, and then I can move the cursor into my data area again, drop the spacebar, and give me the same information, and it's going to stay with the data even when you turn the cursors off. So it will follow the data to the left of the screen, and eventually it will scroll off. It won't get stored in the normal data file, but it is data that you can see visually. If you want to save this data now, you can print it. There's a print button, and you can also copy it to the clipboard. And if I copy it to the clipboard, I can show it to you in my Snagit program. Let's see how we're going to do that. So I will be able to show you this in my Snagit program. See if we can get this to fit. So this was what was on my clipboard. I did a file new from clipboard, and it pasted it in. And it's pretty much exactly what you saw on the screen. It's got the axes, it's got the colors, and it's just got the plotting area. It doesn't have the rest of the area. Let's get that out of the way. So I guess part of what I always try to emphasize when I'm teaching how to use DASYLab is play around. Pay attention to colors. There's some colors that don't go well together. Some of the neon type colors, the bright greens, the bright pinks are not very easy to look at, but they can be used to emphasize different things. So I typically don't recommend, for example, that you make let's just do it to the background, that you pick a bright pinky color to be the background for your screen. It can be hard to read. It can be very stressful on your eyes and give you eye strain, or certainly make you not want to look at this. But your colors are your choices at what you want to emphasize and how you want to emphasize it. There is a reason that a lot of applications, including DASYLab, tend to stick to the grays. The grays are easy to look at. Oh, I didn't do it in the right area, did I? Colors and lines. I want the background not to be pink. And I want the DASYLab line, I like that blue, to be that lovely blue. So this is your design, your choice. How do you want your application to look?
Next, I want to take this same worksheet and turn it into a multi-channel data logger. I want to add a channel to each of the modules in turn. I want to connect them all together, and then I want to review the resultant data file. We'll look at how the displays change and some of the things that you can do within the displays to be able to display, for example, the digital meter on one row instead of a column, or the chart recorder to display on one chart instead of on multiple charts.
Starting with the worksheet that we've been working on so far, the first thing I'm going to do is minimize the displays to make it easier to work on the modules. There is a Minimize All Windows button on the function bar. If you click that, now the displays are minimized somewhere off on the bottom of my screen. I am going to add a channel to all of these modules to be able to make this a multi-channel application. My USB 201 actually only has data connected on the first channel, so any subsequent channels will be reading a default floating value. Open the properties for the analog input. The analog input module bar is different from the other module bars because it has a fixed number of buttons. These buttons correspond directly to the input channels associated with the device. So on the USB 201, I want to read channels 0 and 1. Double-click on channel 1 to tell DASYLab that you want to read that channel. And you can see that the button changed from a disconnected plug to a connected plug with a little lightning bolt on it. The green channel is the channel for whom the information below the channel bar describes. The red button is an activated channel, but not the current channel that you're looking at. So this is channel AI1. If you click on channel 0 and make that green, now you're looking at channel AI0. You can name these channels at any time. This is my signal. And on channel 1, this is going to be signal 2. Depending on the device, you may be able to change the input type, you may be able to change the units, you may be able to change the limits. I'm using a USB 201, which is very fundamental, and it only allows you to read voltage and in a plus or minus 10 range. Click OK. This module now has 2 outputs. I want to do the same thing for each of the modules in turn. Open the properties for the scaling module. And instead of having fixed buttons, I have a plus and a minus to be able to add channels sequentially. Channel 1, when I click on it, has the default linear function of multiply by 1, add 0. So we'll just leave this data channel alone. It will remain volts. I'm going to click OK. Change the digital meter next. Add a channel. We don't need to do any other settings here. Open the recorder. Add a channel. Open the right module. Add a channel. While you're here, it's a good time to change the file name. This is going to be different data than the previous exercise 1 data. So I'm going to change the file name and call this one exercise 2. I'll click open, and now the data is going to be saved that way. I didn't change any of the other settings here. I simply added a channel. Click OK. Now wire this up. You can use the touch and connect method. So just touch the 1 to the 1, and DASYLab will draw the wire for you. And you can rearrange this to make this as neat or tidy as you want it to be. I like things very orthogonal. So I have my modules up here. We're connected. I can restore the displays. Now, when you look at the chart recorder, it has 2 charts in the window. It has my minus 20 to 20 chart, and it has the plus or minus 5 chart that's going to go with the new data. The digital meter also has 2 displays, one that doesn't have any data in it and one that has data from the last time I ran it. Click the start button. And now both these channels are writing from the left. I have a very slow sine wave right now on the first channel. Let me increase the frequency of that a little so we don't get bored sitting here waiting for it. All right, so now we got a slightly higher frequency going. I'll give it a slightly higher amplitude. So now we've got our original signal. The other signal, second signal, I can't do anything with. We're seeing that it's a 1.76, and if you squint and look at it, you might agree it's probably 1.76 on the chart. So we're not disagreeing with the data that it's giving us. Now, I said that I was going to look at making these displays look a little bit different. One thing you can do for the chart recorder is plot all of the connected channels at the same time. There are 2 buttons on the chart recorder function bar. One, when you hover over it, says One, when you hover over it, says one window, and the other one says multiple windows. The default mode for the chart recorder is to display each input in its own chart. Now, if you click on the one chart or one window, it's going to plot them both on the same chart, but it's plotting them both on their own axis. So we've got the foreground channel is plus or minus 20, and the straight line channel is plus or minus 5. Both of these are printing in a blue line. Let's change the colors and lines and change input 1's color to a slightly different color. Let's go with a dark green. So now we've got a dark green. Doesn't show up so well on my monitor. I'm not sure how it's going to look on the recording. But we've got the two lines. They're plotting on their own axis. Can I display that second axis? Yes, I can. In the axis menu, there's an option called Scaling Assignment. Scaling Assignment gives you up to 4 axes that can be displayed out of a maximum of 16. Only 4 can be displayed. Right now, input 0 is on the first axis. If I click on input 1 and click on the angle bracket, I can display the second axis with input 1's data. What it will do is it will put it over on the right, and if you had 2 more, then the third one would be on the left again and the fourth one would be on the right again. The colors are your indicator for what data channel you're looking at. The color matches the line color, and it matches the color of the line shown in the legend at the bottom. So that lets you not modify channel 1's axis, but rather to view the axis. Now when you switch back to 2 axes, both axes stay over on the left, but it will remember that you had a single or both axes displayed when you go back to the one window mode. The other thing that I said I would do is I would show you how to set up that digital meter, so instead of being stacked, the meters would be side by side. That's a setting that's actually in the digital meter module on the work area. It's not something that I have a menu to change on the meter. So I'm going to go to the work area and double click, because I'm running, to open the properties for the digital meter. And I want to do a couple things here. One of the things I can do with the digital meter, I can click on the options button and I can ask it to display the channel name because it isn't right now. And I can have it put the unit in line with the value. So instead of PSI being underneath, PSI will be in green beside it. What I'm suggesting we change is the number of columns. I have 1 column. I'm going to make it 2 columns. Click OK and click OK. And now we have signal 1 and 2 side by side. I'm just going to keep rearranging things to make it look readable on the screen. There was another setting in there that you may have noticed that it's worth experimenting a little with. Open the properties again, go to options, and say horizontal alignment. Now this one doesn't always work as well as I want it to do because of the way the font's size. But what this does is it's keeping them stacked, but now the channel name is over on the left and the values are on the right. So that wasn't what I wanted. I'll go back, I'll put it back the way I wanted it, which was not horizontal alignment and 2 columns. You can also change the total number of digits that are displayed here. Digits includes the sign and the decimal place. So you always need at least 2 more digits than the numbers you think you're going to display. If the module has just the pound sign character in it on the display, then it may just simply because you don't have enough digits to be able to display it. So by saying 10 digits, we're making it very wide, You can size it back again a little. The font is going to resize based on the size of the module right now. That was a setting in the module under fonts to automatically resize it. So now we have a 2-channel application running. I said I'd show you the data too. So let's stop the measurement, open the data file, drag it over. So now I have an exercise 2 CSV. I will open that, and I'm going to open it in my text editor so we can see what the raw data looks like in the CSV file. So this is my text editor. It has a header on it. When it's text, the information in the header gives the timestamp as fractions of a second. So it's 0.001 seconds. You turn that upside down, that becomes 1,000 samples per second. We know we stored it with a block length of 100, but once it's into an ASCII file, the block disappears. It's just a series of data. So now we've got the measurement starting at time 0, and as the data changes, everything changes, and there are a lot of lines in this file. We went all the way down to the bottom and clicked. This ended up being 393,000 lines for the 5+ minutes that we were running. So the ASCII data format stores off a lot of data. Okay, what else happened here? So measurement time, the channel name was signal 1 and the channel name was signal 2. The unit came with it in PSI and the unit came with it in volts. One of the things I always do in my DASYLab is under the options menu, under global settings, I configure it at the start and stop of a worksheet to copy the channel names when the measurement starts. That way, you start with the channel name where the data originates in the analog input. I called it signal 1 and signal 2. It has voltage here, and then the scaling module changed the units for signal 1 to PSI. If you want to change the name of a channel in any module, you would do that by clicking on the channel name checkbox, and now you can type in a different channel name than the one that was copied down the line. Units are always going to follow, so that by the time you get to the right module, we have a #0 for the unit. That says take the unit off the channel. The last exercise of this module is going to be data playback. We want to read the stored data that we've been storing using the write module. We're going to read it using the read data module. You could also use DDE input or ODBC input to be able to read data. We're going to first show you how to read data with a DDF or the DASYLab format. That's easy. It's easy because the DASYLab data format is our native format, and we understand how to interpret the data in the file. We're next going to read data with an ASCII file format. It needs configuration because ASCII files can come from applications other than DASYLab. With DASYLab 2020, we can easily configure the data separator that was in the file as well as the date and time format. That enables us to handle tabs, semicolons, and commas. It also allows us to handle European and US time formats. We'll create a new worksheet. We'll add a read data module from the files group. We'll put it onto the worksheet, and we'll open its properties to select the file that we've recently created. We'll then take and display the data onto a YT chart and a chart recorder. We could also do a bunch of other stuff at this point because it doesn't matter whether this data came from a file or whether it came from your data acquisition device. I want to start with a new worksheet. So the first thing to do is to save this existing worksheet. I'll do File, Save As, and I'm going to save this as Exercise 1. And then to create a new worksheet, I need to do File, New. File New clears the memory and starts with a fresh worksheet. I said that I want to create a Read Data module. That's in the Files group. So click on the Files group to open it, drag out the Read Data module. The Read Data module is unlike most other modules that you're going to look at. It doesn't have a channel bar, and it doesn't have the same configuration information. Everything is driven by the file. That means the file has to exist before you can set up a read data. Click on the File ... button on the lower right and browse through the files that are available to you. DASYLab installs 2 files, and we created exercise1.ddf at the beginning of this. Click Open. DASYLab shows you the information that's in the header of that file. So this was stored in text, and it says that this is data that I did on the 15th and around noon. It has 1 channel in it. It's got an AI0, and we called it PSI for units. So click OK. Now I want to look at it, and I said that I would set up a YT chart, and I want to do these in series like I had done in the previous example. So I'll check the copy inputs as soon as the dialog box opens. Click OK. Wire it up with the touch and connect method, and then a chart recorder. So I want to be able to visualize the data in 2 different ways. I'm going to restore both displays. They're off screen, so let's bring them into the screen. This is the chart recorder, and this is the YT chart. They look similar, but they have different functions. The chart recorder wants to be a piece of paper. It wants to be like the old paper recorders where you just had a spool of paper and it continually printed on it. The YT chart wants to be an oscilloscope. It has a refresh display that's just going to constantly refresh its data. The duration of the refresh depends on the data that you're reading. And specifically, it's going to be the block size of the data. With the DASYLab format, the DDF format, DASYLab knows what the block size is. So I'll click the Start button. And now I'm reading that data back. On the recorder, it's a big red blob. On the YT chart, there's might be something. I can, in the YT chart, auto scale. Now, this is the function you were looking for in the chart recorder, but it is in the YT chart. I'm looking at 100 milliseconds worth of data, and it looks like the data originally started out fast and it slowed down, so we're not seeing a full cycle of the data. When we are done reading the data, the file will show us an end of file. But initially, DASYLab is reading the data back at the same rate that you stored it. So let me see, this is showing me, let's do plus or minus 20 on this. So minus 20 to plus 20. And note, I'm doing this while we're running. So that's what the data looked like. It was fast data, and then it was slow data, and it's going to scroll off to the left now because I didn't give us enough time on the chart recorder for the amount of data that was stored in the file. So just to get a jump on what we'll do next, I'm going to increase this to 5 minutes. And I am going to do curve from left, and I will do a fixed time axis. And I won't change anything right now, but this is while I was running through this previously, this is the data that got stored. And that so doesn't look like 5 minutes, does it? 5 minutes. That looks more like 5 minutes. So we're still replaying the data. I don't know how long this is going to take, so I'd like to speed it up. I'll stop the measurement. open the properties for the read module, and I want to uncheck this output in real time. There's no indicator on here how long the file is to begin with. You may know, you may remember, I don't. So now I've got read it back, and DASYLab is going to read it back as fast as it can, and it's going to replay all that data, and we'll get a sense of how much it is. At some point it's stabilized. We're well over 10 minutes now. The YT chart's screaming along, so let's try this again. I'll stop the measurement. And this is, if you send me a data file, this is the kind of thing that I'm doing. I'm trying to see how much data is in the file and to see how we can read it. So now I'm going to do this again, replay the data. You can see the changes in the data. This is now a 20-minute window, and hopefully that will be enough to reflect all the time that was in that file. It's not really fast, but it's still much faster than waiting the 12 minutes that it was going to take to replay all the data. So now if I zoom in on the chart recorder, you can see that the data is here, and I can scroll through all the time of the data up to this beginning data, and I'll zoom in even more here to see what that data was. All right, so features of the chart recorder allow you to create the scroll bar that lets you look at all the data in the chart, or to zoom in and zoom out to be able to get a fuller view of the data. You can configure this module up to the maximum time allowed by DASYLab. I'll click on the X-axis button, and DASYLab says I could probably display about 156 minutes. This data was collected at 1,000 samples per second, so that's not too bad. That's a lot of data in that screen. Now the YT chart was busy showing me 1/10 of a second. And it was auto-scaling it. So I'm going to turn off auto-scaling for this next piece. I'm going to go into the X-axis settings for the YT chart, and I'm going to change this to be able to display a second's worth of data at a time. We haven't talked about blocks yet, but I know that I've got a block of data every 1/10 of a second. So if I display a second of data at a time, I want 10 blocks. I also want to change the y-axis setting. This is a silly error. I'm not sure where it comes from, but you can tell DASYLab it's wrong. Maybe not. Let's try that again. Stop the measurement. Go into the x-axis settings. So you know this is a real class because I'm getting error messages. All right, so now this should be able to display a full 10 seconds. What is the input block size? There we go. So now it's showing you a minute's worth of data, and we have data that is between plus and minus 20. So I'll change the y-axis setting to be minus 20 to 20. All right, that's good. So that's giving me an idea of the data, an instantaneous snapshot. It's updating 10 times or once per second. You could slow that down and show more time if you wanted to. Say you wanted to show 10 seconds of data worth at a time. And now this module is updating every 10 seconds, and you're getting a sense of what's happening. So the YT chart is an instant read of the last interval of data, and the chart recorder is trying to keep some history, depending on how much time you're working with. All right, let's stop the measurement because we can't make any changes to the file while we're reading. That was a DASYLab DDF file. We read it back at the same sample rate that it was being written. We read it back with output in real time turned off. You could have read it back with the original date and time. Please note, if you're using the evaluation version, this won't work. But if you are using a licensed version, you can check the original date and time. And again, DASYLab is going to figure out what's happening. But in order for that to work, I need to say, give me time. And I also want to go into the recorder module on the work area and say, show me the date. So that was two things I changed. One was to change the axis to time and then display the current date. And what that will do when I replay the file will show me that this file was originally written on the 15th around 12 p.m. Well, that was fun. Okay, click stop. If you like this worksheet, save it. So File, Save As, and this was Replay DDF. The next thing I want to do is replay one of those ASCII files that we've written. We've written CSV files. So DASYLab is stopped. Open the properties for the read module. And we're going to change the file. So click on the File button at the bottom. It only shows you the DDF files. So you have to select the type of file you want to read. And in DASYLab 2020, ASCII CSV format is supported. Now I can get an idea of what I was doing. I've got exercise 2, which was the 2-channel application, and exercise 1 was 1 channel. So I'm configured for 1 channel right now. I'm just going to read 1 in. Click Open. DASYLab knows it wrote the file. It knows when it wrote the file. It knew that it had a block length of 100 and a sample rate of 1,000 samples per second. It interprets the information that says number of channels in the bottom of this dialog box to say it's going to read 1 channel. So the first thing to do is, what's it going to do? Let's click OK and click Start and see what's happening. DASYLab is replaying the data, but I'm pretty sure I didn't have a 5-minute period on that data. I don't think it's reading it back at the right sample rate. So I'm going to minimize the chart recorder and show you a technique to see what the sample rate is. Click on the wire while you're running. At the bottom of the screen in the information area, it's reading the data back at 10 Hertz. That's not what I wanted. All right, so stop the measurement. Restore. Go into the read module. How do I get it to give me the right sample rate? If I click on Option ASCII, it's defaulted to 10 samples per second. I can force DASYLab to correctly interpret this file. I'm going to make it a comma-separated file. The decimal format is my Windows format. The file was stored with measurement time. So I'm looking at the header of the file to see that it says measurement time in seconds. So I'm going to tell it to evaluate the time information. And it's stored with measurement time in seconds. It does not have a date in this on the data channel. So you're going to have to interpret the date yourself. What this should do, however, is allow me to replay this data at the correct sample rate. And that's looking better, but it's taking a long time to write. This is going to segue nicely into the next module, because right now the block size is 1. And the block size of 1 with a sampling rate of 1,000 means that DASYLab is working really fast. It's like pedaling with a really low gear. So I'm going to click Stop, and I'm going to go into the Read module and in Options ASCII, and I'm going to change the block size here. So I'm going to override its default and make the block size 100 to match what the file was originally stored with. And this should make this work better. So now DASYLab isn't having to punch quite as hard. And it's able to replay that data back pretty cleanly. Different file, so the data looks different. We've got data that was higher speed, and then while I was recording, I slowed it down. So one of the things I hope you saw is that you will get an end of file, EOF, on the actual read module icon when the file is completely read. There are a bunch of other settings in the read module. You can let it replay continually. Instead of stopping at the end of the file, you can get it to just keep reading the data over and over again. You can show a little status window that shows you how far you are through reading your file. You could force a new sample rate on it, but you would do that in the options ASCII before you would do it out in the outer dialog box. ASCII just has some special stuff going on. So click OK. I now have somewhere on my screen a new little box. Oh, here it is. So I now have a new little box that says that I am reading this exercise 107 CSV. If I click start, you're going to see that it's going to show the position in the file as it plays out. Okay, so not a lot of time. We're not going to spend a lot of time on the read data module. It's pretty powerful. There's a bunch of features you can do with it. And this is the type of thing that if you have any questions on, give us a call. We may be able to help you do whatever you need to do with your custom data. I think that's the end of this module. We'll pick up again with another set of exercises in Module 2. Thank you for taking the time to listen to this, and I hope you enjoy DASYLab.